Throughout history, science has always been deeply rooted in the study of the physical world, the tangible, measurable aspects of life. From the rise of early civilizations to modern technological advancements, scientists have focused on understanding what can be seen, touched, and quantified. The spiritual phenomena, ghosts, dreams, and other unseen experiences were often dismissed as mere illusions or myths, not worth serious scientific inquiry. Mainstream science looked at these phenomena as nothing more than superstition, something that couldn't be measured or verified within the limits of empirical evidence. However, as the frontiers of physical science continued to expand, fewer and fewer mysteries remained to be discovered in the material world. In response, the focus of science began to shift, turning its gaze inward to the microscopic and quantum levels. What we call quantum physics emerged as one of the most profound breakthroughs in this journey, a realm of discovery so strange and counterintuitive that it defies our understanding of reality. Quantum physics, with its perplexing findings, has brought us to the threshold of understanding not only the unseen world, but also how it functions. Can this finally bridge the gap between science and spirituality? Many of the concepts and discoveries within quantum physics seemed absurd at first because they don't align with the familiar laws of the physical world. Particles that can exist in multiple places at once or behave differently when observed, these strange behaviors are hard to accept. Yet these findings, though bewildering, have increasingly been found to align with experiences that were once considered spiritual or mystical. What's even more fascinating is that in earlier times, scientists often ignored or discarded these discoveries because they couldn't make sense of them in the context of the physical world they knew. Now, with deeper understanding and acceptance of quantum mechanics, we're beginning to realize that the veil between the physical world and the spiritual realm is thinner than we ever imagined. Through the lens of quantum physics, we are not just unraveling the mysteries of the material universe, we are slowly beginning to glimpse what lies beyond, in a realm that has long been thought of as untouchable, but is now being examined with scientific rigor. One such physicist who has played a pivotal role in bridging the gap between the material and the quantum realms is Brian Cox. A renowned British physicist and professor at the University of Manchester, Cox is best known for his work in particle physics and his ability to communicate complex scientific concepts to the public. He has been involved in several major experiments, including those at CERN, the European Organization for Nuclear Research, where scientists conduct groundbreaking research into the fundamental particles of the universe. CERN is also the facility that's rumored to have accidentally created a black hole by accelerating particles, an event that some self-proclaimed future time travelers have even suggested could have opened gateways to different timelines. Beyond his academic accomplishments, Cox is also a well-known science communicator, hosting popular TV series like Wonders of the Universe and Wonders of the Solar System. His ability to explain the most intricate aspects of quantum mechanics in a way that is both accessible and engaging has made him a central figure in helping people understand the strange and fascinating world of quantum physics.
Go back to the Greeks, so Aristotle and very clever people, but they thought the Earth was at the centre of the universe. Why? Because it feels like it. It feels like we're not moving, and that's quite a deep point actually in physics. It's like, why is it that we're flying around relative to the sun very fast at whatever speed it is, 18 miles a second or something like that, and the whole solar system's going around the Milky Way galaxy and so on? why is it that we don't feel it? The Greeks quite naturally said, well, because we're at the centre of the universe. They also said everything falls towards the earth, so therefore the earth must be at the centre. It's natural. And actually it's quite a deep thought to understand why it doesn't feel that we're moving. You have to go all the way to Einstein, really, for someone to take that very seriously. Well, he said, well, that the idea that you can't tell whether you're moving or not demolishes the notion of absolute space.
When Brian is asked to explain quantum mechanics in under a minute, he smiles, not because the task is easy, but because the heart of the subject is surprisingly elegant.
Well, the most basic version I know of is Feynman's version, which essentially says particles are particles, and they hop from place to place with a particular probability. And the probability that a particle that's at some place will be at some different place later is given by a very simple rule. It uses a quantity called the action, which is to do with the mass of the particle and the time and the distance. So you basically calculate these little quantities, which are to do with something called the action, and you add them up. So if I start with an electron in one corner of the room, and I say, what's the probability at some time later it'll be somewhere else? Then at every point in the room, you can assign a probability that it will be there at a later point with one simple rule, and that's it. Now this is called the path integral formulation of quantum mechanics. That underlies everything else. You can get the rest from that. So it's a simple rule. It says, what's the probability a particle will move from A to B? That's it.
He says that particles simply are, and they move not by following set tracks, but by exploring possibilities. That's right. At the deepest level of nature, reality isn't built on certainty. It's built on probability. He draws from Richard Feynman's iconic picture of particles trying out every possible path at once before deciding on a final outcome. It's not that a particle chooses a road and follows it like a car on a highway. Instead, imagine it like a single thread of energy unraveling into thousands of ghost-like tendrils, each one testing a different path, looping, darting, even moving backward in time. In the end, the route we see is just the one that made the most sense after all the other possibilities cancelled out. It's as if a pebble thrown into a pond created not one ripple, but a swarm of overlapping ripple patterns that interfered with one another until only one remained. To calculate which outcome wins, physicists use something called the action, a formula that accounts for mass, distance, and time. What's so remarkable, Cox explains, is that this system doesn't just apply to tiny particles. It underpins the workings of the entire universe. Everything from the atoms in your body to the galaxies spiraling in space abides by this strange but consistent rule. He likens this invisible rule to planning a road trip where your GPS doesn't just calculate one best route. Instead, it simulates every conceivable route, some winding through deserts, others cutting through oceans, or even imaginary tunnels through the earth, and only then settles on the route you're most likely to take. Reality, it seems, is the average of infinite possibilities. But while this theory paints a picture of elegant chaos, there's something more haunting that emerges when you scale it up to the size of the cosmos. In a long-form conversation on the Joe Rogan Experience, Cox reflects on our solitude in the vastness of space. There are 2 trillion galaxies in the observable universe. Each contains billions of stars and likely even more planets. The numbers scream that intelligent life should be common, but maybe it's not. He wonders whether the very process that gave rise to life on Earth is incredibly rare. Maybe complex life is so fragile and takes so long to evolve that it only happens under the rarest conditions. If that's the case, then we may already be the most successful civilization the universe has seen. A lonely thought, but also a privileged one. Even if there are alien civilizations out there, the odds of contact are staggeringly slim. Galaxies are not just far, they're impossibly far. The closest major galaxy, Andromeda, sits 2.5 million light-years away. That means even if a signal was sent from there, when early humans first discovered fire, we still wouldn't have received it yet. Still, Cox offers a twist. Einstein's theory of relativity shows that time and space aren't fixed. They bend. At near light speeds, everything changes. For someone traveling fast enough, time slows down dramatically. Space in front of you compresses, like squeezing a tunnel. For example, at CERN, protons are accelerated close to the speed of light in a 27-kilometer ring. But from the perspective of the proton, the ring shrinks down to just 4 meters. That's how warped space becomes when you're moving that fast. It's as if you're running on a treadmill that gets shorter the faster you go. At top speed, the treadmill might shrink down to just 1 step. This is the kind of warping that opens up possibilities like interstellar travel, not by breaking the laws of physics, but by using them. If a spaceship could travel at 99.9% the speed of light, the trip to Andromeda could feel like just a few minutes for those on board. But back on Earth, millions of years would pass. When they returned, if they ever did, civilization might no longer exist.
If you travel close to the speed of light, then distances shrink from your perspective. And the one number I always have in my mind is at the Large Hadron Collider at CERN, the protons go around the ring, which is 27 kilometers in circumference, and they go around at 99.999999% the speed of light. At that speed, distances shrink by a factor of 7,000. And so that ring is something like 4 meters in diameter to the protons. So according to laws of physics, if you can build a spacecraft that goes very close to the speed of light, you can shrink the distance to the Andromeda Galaxy. And so you could traverse across that distance in principle in a minute. However, the downside is that if you came back to the Earth at that speed to tell everybody what you'd found, at least 4 million years would have passed on the Earth. But getting to chat to everybody about what you found is forbidden.
What's even more incredible is that we already see these effects at work in everyday life. GPS satellites, for instance, orbit the Earth at high speeds and relatively high altitudes, where gravity is weaker. Because of both their velocity and position, their clocks tick differently than those on the ground, off by about 30,000 nanoseconds each day. If engineers didn't account for that, your navigation apps would lead you miles off course. Light travels a foot every nanosecond, so even tiny errors create huge displacements, and light itself behaves in the strangest way of all. A photon, the particle of light, experiences no passage of time. From the moment it leaves a star and travels across the cosmos to strike your eye, for the photon, the journey is instantaneous. There's no before and after. Time, from the photon's point of view, doesn't exist. It's not even frozen. It simply isn't there. And that's why nothing with mass can ever travel at the speed of light. It would require infinite energy, and it would mean time stands still.
How can you not know what time is? I think Einstein once said that it is the thing that you measure on a watch. But he said that as kind of almost a joke, because you assume in Einstein's theory there's a thing that the watch measures. But what actually it is, at the deepest level, is a good question. It's interesting, the study of black holes is forcing us towards these theories. It's not that we had the theory space and time emerging from something and decided we could check it by thinking about black holes. It's come the other way round. That almost makes the universe look in some ways like a giant quantum computer, which is not to say that we live in a simulation, before you ask, but it just looks like there's a description of the universe that looks like a quantum computer. That doesn't have the concept of space or time in it.
It's like a blink that never happened, yet changes everything. For light, reality is one unbroken moment. Cox says, this doesn't make the world less mysterious. If anything, it makes existence more miraculous. The fact that we, made of atoms governed by randomness and probability, can contemplate the curvature of space and the uncertainty of particles is an astonishment in itself. Science, to him, is not the removal of wonder, it's the deepening of it. The more we uncover, the stranger and more poetic the universe becomes. As quantum physics continues to challenge our understanding of the universe, it uncovers ideas that might offer an intriguing connection to spiritual phenomena. One of these possibilities is the notion that everything and everyone may exist everywhere, every time, all at once. This concept starkly contrasts with the way we, as physical beings, experience reality. In our everyday world, we view existence as linear. Time moves in a straight line, and things happen in a specific order. For example, we know that Abraham Lincoln existed between 1809 and 1865, and we expect to encounter him only in that period, not in the present day or the year 1000. Similarly, we tend to believe that a person can only exist in one place at one time. This is how our physical world limits our perception. However, many near-death experiences and spiritual teachers who have successfully projected themselves out of their bodies describe a very different reality, one in which time doesn't exist in the same way, and they can be anywhere, at any time, in their spiritual form. Time seems irrelevant in this realm, with only a sense of the flow of things. This perspective mirrors the quantum principle that particles can exist in multiple places at once, and time may not be as linear as we once thought. Now let's consider the concept of reincarnation. From a physical standpoint, we tend to view each lifetime as a long, drawn-out experience, often filled with suffering, particularly when physical pain is involved. Yet, what if all of our lifetimes were running simultaneously, occurring all at once? If we are to apply the idea of quantum possibilities to this, we might begin to understand reincarnation as a series of attempts at different possibilities, all leading up to one final, decisive outcome. The linear perspective we hold as humans might make us view reincarnation as a long, agonizing process. However, from a quantum viewpoint, perhaps all these lifetimes are simply different possibilities being played out at the same time, offering us endless chances to evolve toward a final conclusion. This resonates with the idea of parallel universes. Could each possibility we experience exist in a different universe, each leading us closer to the final version of ourselves? This feels like one of those time-looping movies, where the protagonist experiences the same events over and over again, forced to relive moments of regret or misbehavior, each time with slightly different outcomes. Perhaps this is why it feels so eerie. There's something deep within our core memory that resonates with this idea, making it feel valid on a subconscious level. This idea connects intriguingly with the accounts of people who have had NDEs, where they claim to have witnessed the Book of Life on the other side. Many NDE experiencers have described seeing a vast library where every life is recorded, with countless possible events and scenarios laid out in these books, even those that were never actualized. For instance, One might see a person at the age of 20 joining the army and dying on the battlefield, but in another version of the same life, they reject that path and run away, choosing to live a quiet life in anonymity. In this vision, both possibilities are presented, and the soul has the ability to experience either or both. Could this mean that both versions of the individual have lived simultaneously, perhaps in parallel universes or through reincarnation? The existence of such a book of possibilities suggests a reality beyond our limited perception, a world where multiple potential outcomes are constantly being explored and experienced. This concept aligns with the idea of quantum superposition, where particles can exist in all possible states until they are observed. Perhaps in a metaphysical sense, the same applies to our lives and our souls. Could it be that we are experiencing many lives all at once, navigating different possibilities, and that the final version of ourselves is only one of many potential outcomes? This raises profound questions about the nature of time, existence, and the spiritual realm. Questions that quantum physics might help us explore as the boundary between the physical and the spiritual world begins to blur.
You know, what we should say is that science, we don't know all the answers. So we don't know where the laws of nature came from. We don't know why the universe began in the way that it did, if indeed it had a beginning. So we don't know why the Big Bang was very, very highly ordered, which is ultimately, as Sean Carroll, actually, you mentioned him, often points out, and he's right, that the whole difference, the only difference between the past and the future, the so-called arrow of time, is that in the past the universe was really ordered, and it's getting more disordered. And that's that necessary state of order at the start of the universe, which is really the reason that we exist. That's the reason, because the universe began in a particular form. We don't know why that was. So we will probably find out at some point, and it'll be something to do with the laws of nature. But so I'm always careful. I don't want to. Science can sometimes sound arrogant, right? It can sometimes sound like it's the discipline of saying to people, well, you're not right.
Yes.
And it's not the discipline of saying you're not right. It's saying this is what we found out.
Hence, they say the universe is constantly moving and projecting, and that every individual, as a fragment, is in this state as well. Could the concept of God be a mechanism that created, maintains, and governs this flow? Would it be an algorithm that does so? Wouldn't this make life more like a simulation running in a giant quantum computer? Are we just particles or characters in that vast simulation? It's fascinating to think about. In the end, we may never have final answers, but perhaps we don't need them. The act of asking, of peering into the unknown, knowing it may never yield, is what makes us human. We are beings of curiosity, born from stardust, staring into the abyss and trying to give it meaning.